And with that, I'm excited to introduce our next presenter on today's Storage EcoCast. That is Mike Koponen. He is a Senior Director of Solutions Marketing at Pivot3. Mike, are you with us?
I indeed am. Is my audio okay?
Yes, sir. You sound good. Take it away.
Great. You bet. Thanks, David. It's great to be with you today. Thanks for joining us. It was also good to see 13% of the audience being from healthcare. I feel like I'm coming down with a cold and a sore throat, so maybe some of the healthcare audience vibe will rub off on me and make me feel a little bit better. As David said, I manage our product and solutions marketing group here, and I'm actually joined by our senior technical marketing manager, Keith Hageman, because we've got a short demo, at the end of this presentation for you. So it's going to be a little mix of the slides and a demo. And I'm not going to, go through what Pivot3 does from a hyperconverged software platform from a complete soup to nuts, standpoint. My intent with the presentation today is just give you, a little bit of a feel for, what it's all about from an architecture standpoint, and then actually hone in a bit more on performance and how we're architected for performance, and even more specifically, how you effectively manage that performance so you ensure your most mission-critical applications, get served, over the other less important ones. And hopefully at the end of this, you're intrigued with what we can do from a business value, from helping your IT infrastructure needs, and just making you more successful in your jobs, managing your infrastructure, that you'll follow up and chat with us. So if you're not familiar with Pivot3, we've been shipping hyperconverged infrastructure solutions, now for over. In fact, I'm going to just play with my little screen here. Yep. Since 2008, we've got systems installed in over 63 countries around the world, and we actually have two facets of our product line. We have hyperconverged infrastructure solutions that are optimized for data center-oriented use cases, VDI, enterprise apps, big data analytics, just supporting a range of mixed virtualized workloads, and then BCDR. But we also have a part of our product portfolio that's optimized for video surveillance and security and IoT application needs. I'm not going to talk about that part of the portfolio today, but if there are folks in the audience whose responsibilities are starting to span taking care and providing the data center-oriented infrastructure for that part of the business, but because of the storage requirements and the networking requirements and everything, you're starting to also assume responsibility for the video surveillance and security and access control and all those aspects of your IT infrastructure. Definitely follow up with us on that, because we can help you solve both of those needs. We're recognized by the leading industry analysts as a leader in hyperconverged infrastructure, whether you're talking Gartner, Forrester. IHS happens to be an analyst that tracks specifically that video surveillance and security space. And what we're recognized for is being one of the early innovators in software-defined storage. Way back in like 2003, we created a software-defined storage platform that we ran on standard x86 servers and sold that as an iSCSI SAN before we took and morphed that into a hyperconverged infrastructure product. I'll talk a bit about how we deliver high performance from an architecture standpoint. We also have a unique way of doing data protection that provides a high degree of storage utilization and efficiency. And then our secret sauce from a software standpoint is also around intelligence management. We have a policy-based management paradigm where we can do policy-based management of performance, data protection, and security, to really simplify, how you take and deliver the performance that's required for the various applications that you deploy on Hyperconverged. And then given that this is a storage flash NVMe EcoCast, I'm going to take and touch on our utilization of NVMe. And from an architecture standpoint, we've been doing PCIe flash and NVMe for some time now, integrated with that policy-based management engine. So I'll touch on that. So just a little bit of who we are in case there's some folks in the audience not familiar. Okay. Now there may also be folks in the audience who just aren't familiar with what hyperconverged infrastructure is. I know so many of you are just heads down on your day-to-day jobs that you may not be keeping track of all the different technologies that exist in the IT infrastructure space. But hyperconverged infrastructure is basically taking your separate servers, SAN, storage networking, and virtualization, and collapsing that into a simple appliance-based deployment model. So we Pivot3 produce what we refer to as a hyperconverged infrastructure software platform. Our product name for it is Acuity, and that software platform runs on a standard x86 server, and you cluster multiple servers together based upon the performance and the capacity requirements you have, and now you have your virtualized application environment and your shared storage system, all part of a unified environment. And hyperconverged infrastructure, also happens to be, one of the highest growth, types of data center infrastructure in the marketplace. You see on this slide, that stat by Gartner, where it's been experiencing a 48% compound annual growth rate, from 2016 through 2021. So you've probably seen a lot written by the analysts in the different publications around hyperconverged infrastructure. So if you haven't seen it, kind of look for information on it and get yourself educated. Now, why are people moving away from separate servers, SAN systems, storage networking, to hyperconverged infrastructure? This is some data from a survey done by a firm called Technology Business Research, TBR, and they do a twice annual survey of customers who have deployed and are looking to deploy hyperconverged infrastructure. And so if you scan down the left of this bar chart here, you see that the customers are adopting hyperconverged infrastructure to simplify operations by reducing costs and making management easier. You see that it's a technology that companies are using to take and replace their legacy infrastructure with what they view as next generation infrastructure. They're looking to reduce their infrastructure costs and operating expenses. Customers are experiencing that hyperconverged infrastructures are simpler to deploy and manage, particularly since you've got your virtualized application environment and the management of the underlying storage infrastructure kind of all combined from an ease of use and just a common management paradigm standpoint. Then the data storage management challenges customers like yourselves just see increasing year on year on year, and so hyperconverged is viewed as a way to help people get their arms around simplifying the management of their infrastructure. So just a little bit of information on why companies such as yours are adopting hyperconverged infrastructure. Now, just another bit of kind of research data before I get into a little bit more of the product type information, is there was a survey done the end of last year, and I apologize, this doesn't show the source of it, but back in November 2017, there was a survey done, and this is consistent with what I see from multiple analysts, where we asked people were asked who had purchased hyperconverged infrastructure, what was the most important hyperconverged infrastructure selection criteria? and you can kind of look down the list here to see, performance. QoS is quality of service. People are looking more and more for management tools that take and simplify, their management of, in particular, performance, in hyperconverged infrastructure, storage efficiency, scalability, on down the list there. And from a Pivot 3 standpoint, we believe from an architecture, from a data services standpoint, we have capabilities to take and address all of these top decision criteria that companies are looking at when they deploy hyperconverged. But I'll let all of you be the judge of that if we engage in conversations post this webcast. So let me get into a little bit of the product portfolio now, and what some of the differentiators are of what we do from an architecture standpoint. There's three pillars that we bucket our capabilities into. Performance, scale, and efficiency. You saw that those were three things that came on top of the decision criteria list there. Performance, we deliver from the utilization of a distributed architecture. I've got a slide here next that does that. In tune with the focus of today's EcoCast, we make use of NVMe flash, both as a read-write tier as well as a persistent tier of storage, and that's under the control of this policy-based intelligence engine, so that we make the most effective utilization of that NVMe flash and ensure that the use of it gets prioritized to what you dictate to be the most important applications running on the system. From a scale standpoint, hyperconverged, by its nature, in terms of it being appliance-based, gives you a simple scalability model. But with the way our Acuity software platform is architected, we indeed confirm and prove out that we can scale in a very predictable and linear fashion, so that when you add another node, you can be guaranteed you can support X number of VDI users or X incremental transactions and such. And then we also have the capability to scale storage and compute independently. And for those of you who looked at hyperconverged infrastructures kind of in the early days, that was one of the knocks on hyperconverged infrastructure, that every time you added a node to the cluster, you were adding both compute and storage and paying the expense for that. Well, what if you just needed additional storage capacity? So with Pivot 3, a node can be a hyperconverged node that you can run application workloads on, as well as the storage in that node participates in the storage pool. Or you can just add a storage-only node that takes and just provides you additional capacity. Or you could take and add a GPU node, if you needed to GPU support, from a graphing-intensive VDI standpoint, or possibly to support some of the analytics applications that take advantage of GPUs. And then efficiency, I mentioned that we have a patented form of data protection. We use erasure coding. We've been doing erasure coding since day one at Pivot 3. We're on our 8th generation of it. So we can take and drive over 80% storage utilization rates with erasure coding, and that can be combined with what we do with compression to drive really high storage utilization rates. Then our hyperconverged operating platform also provides very low overhead on the system, and that was one of the concerns about hyperconverged infrastructures early days too. Is gosh, I'm running both application workloads and having this thing act as a shared storage system, and there's this additional layer of software on there that's that hyperconverged operating system, if you will. Gosh, isn't that taking and consuming compute resources that should be used for applications? Well, over the years, we've really refined the efficiency of our Acuity software platform, so it consumes less than 5% of the compute resources in a node. So you've got all the rest of those resources available for your application workloads. So those are the three pillars that we bucket our capabilities into. And there's a slide at the end here that the system comes complete with all the sorts of data services that you would expect in a typical storage system in terms of snapshots, application-aware snapshots, integration with VMware services like VAAI and such, replication, compression, security, encryption, all those sorts of things. But let me just dive into now kind of the performance aspect of things and our utilization of NVMe, given that that's the nature of the EcoCast today. So this slide just has a simple, graphical depiction of a node, a hyperconverged node. And in our product portfolio, we make use of hard drives, SSDs, NVMe flash, and memory. So there are various nodes in the family that can have all of those storage media types, or maybe just NVMe flash and HDDs and memory. And so the software platform takes advantage of having multiple types of storage media in a node and in a cluster. And the NVMe flash in particular is used as a read-write caching tier as well as a persistent tier of storage. And I'll show you in a minute, what we do from a performance quality of service standpoint, because we can take and control with that policy management engine, what data lives up in that NVMe flash to ensure that your the applications that you dictate that are most important from a performance and a response time standpoint, their data will leverage that NVMe flash more than other applications that have less of a need for it. Okay? So then as you take and build out a cluster, let's say you have a cluster of 3 nodes, we have the ability to take and pool all of the resources within that cluster. So any application VM running on any node in that cluster gets the benefit of all of the resources in all of those nodes. So if you have, let's say, 12 disk drives in each of those nodes, you've got 36 disk drives. The data from that VM will get the benefit of all 36 of those drives, or all the SSDs, that are aggregated between all the nodes. And that includes the cache. We have a concept that we call global cache, where the cache from all of those nodes is pooled into a global cache mechanism. And so all the VMs, regardless of what node they reside on, get the benefit of all the pooled resources in aggregate across that cluster. And so that contributes to driving up performance. It results in being able to support a higher density of application VMs per node and per cluster. Now when we look at what companies want to do with hyperconverged infrastructure these days, they want to take and use it to take and consolidate multiple application workloads. They don't want to take and use it just to silo a particular workload in the data center. So they want to be able to confidently consolidate multiple mixed application workloads on it, including mission critical or latency sensitive ones. And so I referred to this earlier. We have what we refer to as the Pivot3 intelligence engine with quality of service. And that quality of service engine is tightly integrated with that data path, that multi-tier data path that I showed you earlier that utilizes NVMe flash. And this intelligence engine has the ability to take and assign policies to volumes, data stores, VMs. Based upon what policy you assign, now the system has an understanding of what applications are a higher priority than others. So if there's periods of contention, the system knows that, hey, you've told it this application is more important than another, so if there's contention for resources that exist, it'll always prioritize what you designated to be the most important applications so that they achieve their performance SLAs. And to do that, it's making decisions in real time on which of those multiple tiers of storage media to place data so that that performance SLA is achieved. And then we also have this same type of policy-based paradigm for data protection as well. I'm not going to go into that today, but we have predefined policies for snapshots, retention periods, et cetera, and then the ability to build a library of user-defined data protection policies as well. This slide just kind of gives you a little simple depiction there of that policy assignment and prioritization. There's 5 predefined performance policies that set targets around IOPS, throughput, and latency. And those 5 policies map to what we refer to as 3 service levels: mission critical, business critical, and non-critical. So if you've assigned a particular volume or data store or VM to say be policy 1, that is mission critical. If there's some lower policy level applications who have spikes in performance, and if that mission critical volume is going to be impacted by it, the system will in real time automatically throttle back the resources that are being given to your non-critical and your business critical volumes or VMs. And so the system is kind of constantly looking at the performance being realized by different applications and how that compares to the performance policies you assign them, and making decisions in real time on how to apply resources and what tiers to take and place data on so those performance SLAs are met. Now, if the system has sufficient performance to meet the performance needs of all the applications that are running on it, nothing gets throttled, nothing gets capped. All of your applications get all the performance that they need. It's only during these periods of contention, that prioritization will occur, and specific volumes may be throttled back, starting with non-critical, to ensure that those mission-critical applications, never drop below their IOPS and throughput floor or exceed their latency target. And the other thing that's neat about this too is you can assign these policies and then you can change them in real time. We give you a lot of performance metrics to look at to see what performance is being experienced and make changes on that, or you can actually schedule policy changes if you know the performance needs of different applications are going to change at particular points in time, like reporting is going to occur for a particular application after 5 o'clock on a Friday. You can kick up that to a mission critical policy and bump something else back down. So instead of me walk through these screenshots, I'm going to turn it over to Keith right now and just walk you through your real quick demo of how the policy engine works, how some of the assignment of policies works, and what happens when you change policies in real time, just to give you a little a taste for what the user interface looks like and what this policy management looks like. Go ahead, Keith.
Thanks, folks. Welcome. I'm going to take over the screen here for a second. And
oh my God, you're going to take control from me.
Can you see my screen?
Yep, can indeed, Keith. Thanks.
Great. So I'm going to briefly talk about the 5 built-in performance QoS policies. As Mike mentioned in his part of the presentation, policy 1 is mission critical. Policies 2 and 3 are business critical, and policies 4 and 5 are non-critical. As you can see on the screen at the moment, I have 9 volumes active as policy 1, 2 as policy 2, 4 as policy 3, and 1 as policy 5. And the targets and the metrics that we achieve in the product are policy 1 has a latency of 1 millisecond. and 125,000 IOPS with a gigabit throughput. And for the volumes that are at policy 1, at one read, one hit, we will start reading ahead off of HDDs or SSDs into NVMe tiers, where policy 3 volumes will take 16 hits or before read ahead will start and those kinds of things. So we have a lot of granularity and simplified control for the users when they set up their policies for their volumes. At the moment, I have 5 VMs running iometer workloads, mixed workloads. Some are at 4K, some are at 16K for database simulation, and it's driving enough performance or workload in the system for QoS engine to actually be enforcing the policies. The first VM has 2 volumes. Volume 1 is actually running at 2.7 milliseconds a second, where the other volume within that same VM is under 1 millisecond. We have the ability to control the performance within in individual workloads as granularly as within a single VM. So this is one single VM, 2 different volumes running at different QoS policies. And the QoS engine in the product is you can just quickly change the performance in real time through a couple of quick steps. So I'm going to take volume 1, which is at policy 5, non-critical. Let's say you take a phone call from somebody and they're complaining about the performance. The admin can come in and change it from policy 1 to mission critical, from non-critical to mission critical, and modify that, confirm the modification. That'll take a second or so, and the volume will change its performance settings in real time. Let's go ahead and change the other volume and modify that. We'll change it from mission critical policy 1 to policy 5 and confirm that operation in real time. And then we'll go back and see the graphs should have reversed as this finishes. There you go. And then, as you can see now, volume 1 has gone. Previously, it was running at that 2.3 milliseconds of latency. It's now, with the real-time changes, we're now running at sub-millisecond in volume 1, whereas the other volume is, of course, reversed. It was at about 1 millisecond of latency, and it is now running at 3 milliseconds of latency, while the system performance actually hasn't changed. It's been running at about 250,000 IOPS, which is a demonstration of the level of granularity and control that we have. You also have the ability through schedules in the system to set this up to be scheduled where you could do these kinds of operations to change, do replication, snapshots, and or policy changes in the product. Okay, that's my demonstration for today. We'll give Mike back his control. Figure out how to stop. There we are. There you are, Mike. Back
Great.
to you.
Thanks, Keith. I'll just touch on 1 or 2 things here and then wrap up, because I know we're getting close to our end time here. I referred to one of the pillars of capability is efficiency, and so this is just a little view of that here. We utilize a patented form of erasure coding, that Pivot3's been doing since its inception, and it provides us the ability to deliver 6 nines availability. We can sustain up to 5 multiple drive failures across the node, or a complete node failure and multiple drive failures. And one of the neat things about this is not only is it kind of up to 80%, 82% storage efficiency, but the ability to survive multiple failures and still have data available. But under these degraded conditions during failures, we maintain over 85% the performance that was being delivered prior to those failures. And that's a result of the distributed architecture, in being able to aggregate all the resources in all the nodes, and present those to VMs regardless of the node they're running on, and then also the utilization of NVMe flash from an acceleration standpoint. Now, I'm not going to go through this, but we have a kind of a broad portfolio of hyperconverged appliances, different form factors, different amounts of compute, storage capacity, et cetera, the ability to support GPUs. And as I mentioned earlier, you can take and combine hyperconverged nodes, storage-only nodes, compute-only nodes, GPU-enabled nodes, all in the same cluster, based upon what your performance and capacity needs are, and how you want to scale going forward. And then this is just a little summary here of some of the capabilities in the intelligence engine that Keith referred to. The middle with some of the capabilities that enable us to deliver the performance that we do. And then on the far right there, we do provide a broad range of data services, all included with the base software. Our model is to take and provide all of the software capabilities, all inclusive in the software. There's no a la carting, software features. So all the sorts of features that you expect in a normal SAN system from a data services, are supplied in this hyperconverged model. So that's it. Couple of URLs there to take and check us out. Just go to the website, and you can find ways to contact us there, and obviously a wide variety of resources. We also have live demos where we do a complete end-to-end demo of the product as well, that we can schedule to do one-on-one, or we run them on a bi-weekly basis as well. So David, any questions?
Yeah, we do have a couple questions for you here, Mike. So first one, Bernie's asking, I don't want to try to pigeonhole Pivot3, but he's asking, what would you consider to be your sweet spot on the number of end users and storage capacity, or is there one?
Boy, that's an interesting question, because we have a really broad range of scalability from a number of users and capacity. I mean, you can start from one node basically, and we have one node of say 12 terabytes, and we have customers running in excess of 20 petabytes in a single location, all under one management domain. So it's such a broad range of scalability we have. It's tough to say that there's a sweet spot. I mean, typical customers will start deploying let's say a half a dozen nodes, and then the scalability is basically unlimited from there.
Okay. And then Todd here is asking, does Pivot3 run on its own hypervisor, or does it run on top of VMware or Hyper-V?
Boy, yeah, good question, and that points out a miss that I made in pointing something out. Our hyperconverged software platform takes and runs on VMware ESXi, so you'll get the advantage of leveraging the full VMware software suite in conjunction to our hyperconverged software platform. So we have customers deployed with us, and they're using NSX, they're using vRealize from a private cloud automation standpoint, et cetera.
Okay, awesome. Well, I think that's all the time we have for questions. There's a few more questions for you there in the queue.
Yep.
But thank you so much for being on today, Mike.
Oh, yeah, you bet. Thanks, David. Appreciate everybody listening in.